this is a question about like fundamental counting principles. So this is kind of setting up things logically. So our question asks, how many ways are there for arranging the letters in the word question? I should have put that in quotes. Okay. If the letters S and T must be together, which they are in the word question, the first thing we need to do is figure out how many letters there are. So we have 1, 2, 3, 4, 5, 6, 7, 8. Now, I've counted 8, but there's a stipulation. S and T must be together. So you can kind of just replace that. Instead of saying ST, why don't we just call it X? Okay. So now how many letters are there? Well, there's Q, U, E, X, because that's ST, I, O, N. So now there is 1, 2, 3, 4, 5, 6, 7. So there are 7 different letters, which means we can now accommodate 1, 2, 4, 5, 6. There are 7 different spots. So if we choose, when we first start choosing letters, we have 7 options. And then as we go down, once that option's gone, there are now 6 options, then 5, then 4, then 3, then 2, then 1. So this is essentially how it's set up. The idea is that is 7 factorial will give us how many there are. 7 factorial.
I think it's 160.
Ooh, it's huge. 5,040, according to this. There are 5,040 different ways to set this up if the letters ST must be together. Now, we did make an assumption, though. We made an assumption that they don't say in here that we wanted the order to be ST. But we can now also say, what if we wanted the order to be TS? Well, we can call TS, we call it STX. Let's call that Y, and that's a whole different question now. Now we're looking at the word QUEYION, and we already know that's 7 placeholders, and that's another 7 factorial, which is 5,040. So we would technically add these two concepts together, and we're looking at 10,080 options for the word question if the S and the T have to be together. And really, we didn't have to do it twice. We could have just taken this number and multiplied by 2 because you either have ST or you have TS. Okay. Is that idea?
Yeah.
Yeah, that's okay.